Similarity in right triangles. The geometric mean of two positive numbers a and b is the positive number x such that a over x equals x over b. And if you solve this proportion for x, you'll find that x is equal to the square root of a times b. So let's go ahead and find the geometric mean of the two numbers given. In this first set, 3 and 12, we can do this one of two ways. First, set up the proportion 3 over x equal to x over 12. So you're just setting up a proportion with those two numbers. X has to go at the bottom of one of the ratios and at the top of the other. And then when you cross multiply, we'll get x squared is equal to 3 times 12 gives us 36. So now when we want to solve for x, we have to take the square root of both sides, and then we'll end up getting x equal to 6. If you remember on the page before, we also said that when you find the geometric mean and you cross multiply, you're going to end up with x equal to the square root of the two numbers multiplied. So we can go ahead and set up x equal to the square root of 4 times 8. So 4 times 8 is going to be 32. And now, this is not a perfect square, so we're going to need to simplify this radical. So we want to break this down. 32 is equal to 4 times 8. 4 is equal to 2 times 2. 8 is equal to 2 times 4. All these 2's come down since they're prime. 4 is equal to 2 times 2. And we want to group in 2's. So one pair of 2's gets out, another pair of 2's gets out, and 1 2 is stuck underneath the radical. So our final simplified answer is x equals 4 root 2. Now let's talk about the similar right triangles theorem. When you have a right triangle, and then if you draw the altitude from the right angle to the hypotenuse, it actually forms two additional right triangles. Now what happens is these three right triangles are all similar to each other, which means their corresponding angles are congruent and the corresponding sides are proportional. Now when you're trying to match the corresponding sides when the triangles are drawn like this, it can be a little confusing. So I'm going to show you how to separate out the three triangles so that we can set up a proportion to solve for the missing side lengths. So we're going to use the diagram on the right and sketch the three similar triangles in the diagram separately. So I want you to take a look at the original triangle, triangle ABC, the big one, and we're going to draw 3 of those. Now if you look at that original triangle, the right angle is in angle B, so we're going to draw that right angle in the same place in all 3 triangles. And then we actually want to mark these angles. Angle A we'll mark with 1, and angle C we'll mark with 2. So go ahead and mark all 3 triangles with the same arc markings for the angles. Now we have all 3 triangles facing the same direction. So the first triangle is triangle ABC, the main one. So we're going to label those vertices. A is marked with 1 arc, B is the right angle, and C is the one marked with 2. Next, I want you to take a look at this smaller triangle in here. That one I've highlighted in blue. And when we go to mark these angles, here we have a right angle here, so because of linear pair postulate, this is also a right angle. So the right angle in the blue triangle has vertex D. So let's label the right angle with D. Then, if you look over here, angle A is marked with 1 arc marking. So we want to label the angle with 1 arc marking with A. And then the third angle of the blue triangle is going to be angle B. So that's going to be this one. Then let's go ahead and take a look at the other triangle. This one I've highlighted in red, and we're going to do the same thing. The right angle has vertex D, so at the right angle we want to put vertex D. This time angle C is marked with 2, so we'll mark this angle as C, and the third angle is going to be angle B. So basically what we've done is we've taken the 3 triangles and rotated them so that they're all facing the same direction. This way we can see the corresponding sides easily. So we're going to go ahead and write the similarity statement for the 3 triangles. If I mark the first one, triangle ABC, we can say that that is similar to the blue triangle in that same order, ADB. And that's going to be similar to the third triangle in the same order, BDC. The idea of separating the triangles will help kind of organize our thoughts visually so that you can see the pictures a little clearer. So let's go ahead and do that same process here. We're going to use the diagram to complete the proportions after we separate. So again, take the main triangle and we're going to draw 3 of those. Then we want to go ahead and mark the angles. Here's the right angle of the main triangle. And then we can go ahead and mark the other ones, 1 and 2. It doesn't matter which one's which. You just want to make sure you mark all of your triangles consistently. Then let's go ahead and label the vertices of the first triangle, J, M, K. So you should always label the big one first. And then it doesn't matter which one you do first, but one of the smaller ones, this one, the red one. So angle L is the right angle. Angle J is the one marked with 2. So that means the third angle has to be angle K. Then we can go to the smaller triangle, this one highlighted in blue. And again, the right angle is going to be angle L. Angle M is marked with 1. And so angle K is going to be that third angle. Now let's go ahead and use the diagram to complete the proportions. So here I want you to find the triangle that has both segments KM and KL. This one has KM, but we don't have KL. This one has KL, but not KM. This is the only triangle that has segment KM and KL. So I want you to look carefully, KM and KL. And we want to match that with JK is going to correspond to KL. So since KL is along the bottom, we want to find the triangle where JK is also along the bottom. And that's going to be here. So since these two sides correspond to each other, that means the missing segment has to correspond to KM, which is going to be this segment right here, JM. Let's go ahead and complete the second proportion as well. So we want to find the triangle that has both segments LK and LM. So we have LK here, but no LM. So here is LK and LM. So LM needs to correspond to segment LK. Since LM is on the right side, we want to find LK on the right side, which is here. Since these two segments correspond, the missing segment that we need is going to correspond to LK, which is along the bottom, so that means we actually want LJ. So we'll do this one more time. Look for the triangle that has both segments JK and KL. So here we have segment JK, and here we have KL. Now, segment KL is going to correspond to ML. So KL corresponds to ML. So that means our missing segment needs to correspond to JK. JK is that side, So we want that to correspond with segment KM. So hopefully you have a better idea now of how to separate the three similar triangles and how to match the corresponding sides so that we can complete the proportions. Here we're going to walk through an example where we need to write a similarity statement for the three triangles in the diagram and find the value of x. So first, let's go ahead and separate the triangles. So again, take that main outside triangle, and we're going to draw three of those. And then we want to go ahead and mark those angles. The main right angle. And then we can mark the others, A and B. So remember, when you're separating them out, make sure that the markings are identical in all three. In the main triangle, A, C, B are the vertices. Then when you take a look at this triangle, we have the right angle at vertex D. A is the one that's marked with 1. So that third angle needs to be C. And then when you take that other triangle, again, the right angle is D. And this time, angle B is marked with 2. And that third angle is going to be angle C. Now we want to go through and label the lengths of the sides that we have. Anytime you see segment AD, you want to label it with 5. So here we have AD, we'll label with 5. And then whenever we see segment DB, we want to label with 3. And then segment AC, we'll label with X. And there's actually one additional segment we can label. We know the two different parts of segment AB, so the whole length of segment AB is going to be 5 plus 3, which gives us 8. So every time we see AB, we can label that with 8. Now let's go ahead and write the similarity statement. The similarity statement, we did this in our first example. We're just going to list the three triangles. If we go triangle ACB is similar to triangle ADC, similar to triangle CDB. So remember, you have to make sure that you follow the order of the first triangle in terms of which angles you're listing in what order, because the corresponding angles have to be congruent. Next, we want to solve for the value of x. So we actually need to set up a proportion. And I want you to find two triangles that have the corresponding sides listed with side lengths so that we can set up a proportion. In these two triangles, we have the left side and the right side of the triangles. And then in this third one, we actually only have the bottom. So we don't have any other triangles to correspond with this one. So we're going to use these top two triangles. We have the side x and 8, the side 5 and x. So we're going to go ahead and set up that proportion. We can put x over 8 is equal to 5 over x, and then we want to cross multiply and solve this proportion for x. So when we cross multiply, we get x squared is equal to 40, and then we want to take the square root of both sides. So we'll get x is equal to the square root of 40, and again 40 is not a perfect square, so we want to simplify that. 40 is equal to 4 times 10. 4 is equal to 2 times 2, and then 10 is equal to 2 times 5. So the only pair we can get out is 2. So we have 1, 2 that gets out, and then 2 times 5, which is 10, needs to stay inside. So here we have the value of x in simplified radical form. That's it for this lesson. I'll see you in class for more practice.